Hi everyone, my name is Lydia and this is what I wish they had taught me about econometrics and introduction. In the last video, we saw OLS as a perfect geometric projection. It was the line that made the residuals perfectly orthogonal or perpendicular to the x. Now, keep in mind, so far, that theory is related to the population. In real life, we never see the entire population, we just get a sample, which is why in this video, we're going to talk about the changes that happen and things we need to be aware regarding estimations that we do when we talk about population or the sample OLS. When we do our estimation and we apply like sample OLS, there is a key concept that comes into play, and that is randomness. Meaning we're getting a random sample out of the population that is representative of that population. When we talk about the population, we believe that there is some true relationship that follows like y equals to beta null plus beta 1 x plus an error term. Okay. Now, in here, in the population, we also know that on average, like the conditional expectation of the error on the x needs to be 0. Now, the true slope, beta 1, that we are trying to estimate here is the one that minimizes the expected squared predictor error, okay, across every possible observation in the population. And we said that the best linear approximation to the true CEF was the OLS. But as we don't observe everyone, and we only have a finite slice of the data, we can't compute expectations. We can only approximate them through the OLS. So what happens when we collect a sample? When we're collecting a sample, we're estimating all over again. Let's say that the beta 1 hat here would be a consequence of us estimating the minimum with respect here again to beta null and beta 1 of the sum of y minus beta null minus beta 1 x all squared. Okay, so same idea. We are minimizing the squared misses, basically what we've missed, what the mistake we've made, but now it's based on the data that we have, not the entire population, which means that every new sample is going to give you a slightly different x and slope and intercept. Okay, because we have slightly different x and y's in that new sample that we're getting. So that's why whenever we're making an estimation and we say our estimated line, y hat is equal to beta null hat plus beta 1 hat x, this is a random line, okay? Because it's been constructed based on that random sample that we got out of the population. It depends on which data points we happen to draw, basically. Now, the slope here, the beta 1 hat, is an estimator, okay? And it has what we call a sampling distribution. Which, because we have many possible values across repeated samples for it. So what would happen is that if we take each one of these samples, we estimate, we collect the beta that we find, we put it in an Excel spreadsheet to keep track of it, we take another sample, we do exactly the same, we collect our next beta and so on. If we collect all of the betas and create, so to speak, a set, we can from there have a sampling distribution of the betas and where we can see how this beta has behaved across all of the samples that we had collected. Now, on average, under OLS assumptions, the sampling distribution should be centered around the true beta. And that's why we love the OLS, because it gives us on average the truth, okay? But again, here I'm using and I'm adding new concepts. I'm talking about OLS assumptions, which we are not covering in this video, but they will be in a future video to make more sense of like why can we actually trust that, hey, this OLS is good and on average is hitting the true beta that we have. Okay. Now, in practice, keep in mind, we only have one sample, one line, one beta. So that means that there should be, or there could be some uncertainty behind it. We don't know the actual spread, the actual range of the possible beta hats that we could have gotten. And that is basically very important in terms of, in our world of econometrics. So the OLS line we estimate isn't basically the final truth. It's an estimation of the population's baseline. We've got basically the best sketch drawn from these observations that we took. And the question would be, is how do we measure that uncertainty? And how do we know whether the beta that we have is like good enough for us to trust? Um, Please feel free to watch the next videos to understand more on the conditions and that need to be fulfilled for us to be more reliant on our beta results. See you next video.